Alright, I'm going to show you what an example of one of our triangle problems looks like when we have parallel lines. So right here we're given a diagram. We see we've got some triangles as we did before, and we're asked to prove that triangle ABD is congruent to triangle DCA. So basically this top triangle right here, we want to prove that it's congruent to the bottom triangle right here. Now we see we've got sets of arrows here, and we should remember that these arrows tell us that those lines are parallel. So for instance, the line AB is parallel to the line CD, and the line BD is parallel to the line AC. And these are what our givens are. So you say AB is parallel to CD, and then AC is parallel to BD. Okay? And these are our only givens because we don't have any dashes anywhere, we don't have any curves. Next thing we notice is we've got a shared side in the center. So that tells us that we use our reflexive property. So by the reflexive property, AD is congruent to itself. So AD is congruent to AD. So I'm going to put a mark here in the center so we know that these two or this line is parallel to itself, and we know that line. Now, since I just learned about my new parallel lines rules, I know that I'm going to be using those since I've got two sets of parallel lines here. Well, if I've got two parallel lines right here and I've got a transversal that cuts them, one of our rules was alternate interior angles. So if I look at AB and CD, this angle right here and this angle right here, these are both inside the set of parallel lines and they're on opposite sides of the transversal. So this is alternate interior angles. So alternate interior angles tells us that this angle and this angle are congruent. And as if you look at them, they do look congruent there. So this top angle would be angle BAD, and the bottom angle would be angle CDA. So that tells us that those two angles are congruent. And so now we have one set of parallel sides, and we have a set of, we have one set of congruent sides and one set of congruent angles. But also AC is AC is parallel to BD. So we know that this line is still transversal for those two. And if I sort of look at it sideways, or if I even flip this to look like that, I see my parallel lines here are cut by the transversal, and this angle and this angle are both inside the parallel lines, and they're on alternate sides of the transversal. So once again, this is still alternate interior angles. So I can still keep the same rule, I don't have to write it again, but now I can say that angle CAD is congruent to angle BDA. Alright, so now I've got two sets of congruent angles and one set of congruent sides, and if I look here, I see my side is in between the two angles in each triangle. So I have side angle side on each of my two triangles. So I can say, by side angle side, my two triangles are congruent. And I'm done.